In this episode, we are going to combine what we've done in the two previous episodes, reading the rules from the whitelist definition in YAML and comparing it to what is being extracted from the pcap file. Here we have all the tests regarding the whitelist definition. Now we need an extra test for the pcap extraction. Tests pcap.py is good. Parse pcap. And now, so I think this. Okay, so this takes a file name. Okay, so let's say file name equals example.pcap and packet equals. Actually, is it even necessary? I mean, we are not going to test, like it's just going to be a single wrapper around what scapy provides. I don't have the feeling that we are going to add more logic around this, because these are already like pretty interesting objects. So, and by interesting I mean like they're coming with all the nice feature that we might want to see. So I'm not even sure that we would really need these tests. Instead, maybe what we would like to do is actually testing, like if we craft our own packets or if we produce similarly looking packets, that we can compare them to a given whitelist. Why aren't we reading the pcap ourselves? It's just because it's a lot of data and we don't have the full control over what's really in it. We could generate a bunch of packets and put them in the pcap, and this would be a bit more valid. Because scapy allows you to do this. Scapy allows you to create a bunch of packets and you put them out in a pcap file. So that would be something that would work. But we don't really. Do we really need the real scapy packet objects? We could just fake them, right? So what would that look like then? So here, let's forget about this. Let's make instead a fixture that will produce the same thing as we have here. Like we're going to produce a bunch of dictionary of objects which have src, dst, and dport, because that's what we are going to look at, right? We could definitely build our own packets also. It's just a bit more tied to the scapy interface. Would that make sense? If I'm not mistaken, you can generate your own packet. You can make your own packets and put them yourself into your own pcaps. So we have the full control. We have the, because when you're writing a test, you want to have the full control over what goes in, so you can check that what goes out is valid. If here we can create our own packets, then we have the full control over them and we don't have to fake them. Because another alternative would be to have like a double or a fake. It would be just like simulating scapy objects by creating an object, a Python object that mimics the behavior of a scapy object. But here we actually can craft our own packets. Let me just try something. So from scapy dot all import port IP, and then src equals st equals nd port equals so the port is not at IP level, no, sorry. So P1 is like this, but then it's not the whole packet. We need more. We need to make some TCP then. Okay, so that's the shortest way to get a valid packet, which looks like what we are going to get from our capture. So actually I could just use this then, and then we can whitelist fixture fake capture, and from scapy.all import IP TCP. And now okay, so now we can make a bunch of packets. I'll just use so 80.443 8080, and in the other way around so this is completely fake, but it's just for the sake of writing the test. Okay, and here we can have like 1 1 1 1, and this one will go to 2 2 2 2. No, and this will go to 3 3 3 3. Okay, at least now we get like a sample return packet. No, so now we want to test if we can compare these and filter out the ones which are whitelisted or not. So we called it test pcap, but it's not really testing the pcap feature in the end. It's more like testing the filtering feature. So test filter, and we need the fake capture fixture. So if I haven't explained this yet, what's a fixture? It's a piece of initialization data that we need to run the test. Every time I'm going to call test filter, I get a fresh sample, so I can alter fake capture, I can do whatever I want. When this test ends, fake capture ceases to exist, and if another test uses fake capture, it's going to use a fresh sample again. So it avoids having side effects. So with PyTest we have the ability to just simulate everything programmatically, so we don't have to care about these. And the fixtures, they are nice because they have a lifespan that you can control. Like by default, the fixture lifespan is set to a function. So when my test function ends, then my fixture ends. We can have fixtures that live a bit longer, like through the whole module here, or through the whole session, and so on. So it's like, I encourage you to read on the PyTest fixture documentation, because it's really good for writing good tests. Okay, so test filter, like tests, it filters packets correctly. And I probably need, so from tcpd filter import read what was the name again? Read whitelist. So I'll need read whitelist, and also I'll need filter packets. So on these set of tests, I'm going to perform a few different tests based on the same input. So I'll keep fake capture the way it is, and I'll just run different samples of whitelists just to see what's the result. So here, what I'm expecting is definition. I'll use this definition and say, okay, my whitelist is going to have name. So let's say I want to say this one is valid, only this one. So name. It's DNS 28888 from localhost. SRC needs to be 127.0.0.1. DST needs to be 8888. Port needs to be 53. Okay. Let's say this is good. Now I have like my rules are read whitelist of definition. And now I have my yet to be written function called filter packets that's going to take fake capture. Packets is fake capture and rules is rules. And that would give me output. And now what's my assertion? What am I asserting? Output of whitelisted. This is a bit long, but yeah, I don't have a better name for the moment. Is, and then I just have good question. Are two packets created with the same features the same? So if I have p1 equals that, and I have p2 equals that, is p1 equals p2? Yes, okay, good. So I could here, I have two options. I can say fake capture, I can say, so my whitelisted output should be just fake capture of 0. That would work. Or I could just say is a list with just that. To be honest, I think the first one is, so yeah, you need to decide, because here this is the most valid test-wise, because you're really expliciting the output. Here I'm saying that, yeah, my list here, I take the first element, so the whitelisted is the first element of fake capture. But fake capture is immutable. You see, it has like, it's a list. So if I just dropped the first item and I whitelisted the second, that would be wrong, but that would still make my test pass. So one good way of preventing this is just not using immutable for that. So, okay. So this is already a bit more solid. Here I can safely say fake capture of 0, and that I'm sure it's going to point to this structure. Of course, if in my, so like dropping a line, it might happen. Modifying the packet itself, yeah, it's a bit more obvious. So it's still not, this one is still not perfect. It's just saving me some typing, and it's easier to adapt my test if I want to. I don't have 3 places to change my test. If I want to adapt it, I just have 2 places, my whitelist and the fixture. So yeah, it really depends on how critical you want to be like how bad you want to be shielded from incorrect behavior. Okay, let's stick with this one for the moment. Assert. Test. Return packets. Return. Oh, could not import filter packets. Of course, it's not yet written, like usually, as usual. Filter packets, rules. Output is, and we could already like white listed and black listed. So at least it's already prepared, we don't have to take care of this. And now for packets in packets. Now that's where it's the whole rule engine going. So if packet, so it's more like if yeah, you need to apply each packet to each rule to each packet, and if at least one rule goes, then you're good. Is there a more elegant way of doing this? Yeah, so we could have like nested for loops, so that like for packet in packets, for rule in rules, blah blah blah. Or we can use iter tools, and iter tools has like a function called product, which takes two iterables and generates all the possible combinations. So for packet rule in iter tools dot product of packets rules. Actually, this is maybe not the most clever way, because, well, let me explain this. This is the best way of combining two different iterators and to explore all possible combinations. But here we don't need all combinations. We need, like, the first rule should trigger, like, should end the inner loop. So for each packet we would still need to run all the rules, but as soon as we have one rule that matches the content of the packet, we should stop exploring all the rules. So maybe if you've got like 50 rules and the third one is the right one and your packet is being whitelisted, then you don't need to explore the 47 remaining rules, right? So let's do it like that. So even though I really much like product, it's not the wisest way of doing it. Like for packet in packets, for rule in rules, and if eval rule or is okay, is compatible, is if matches packet rule matches, then output dot whitelisted. Output whitelisted append packet, and of course break else. So for else means if you have exhausted all the options here, then you do this. So if I have been through all the rules and none of them succeeded and I didn't break and I'm still in the for loop, it means that nothing applied. So in this case I should have like blacklisted. Return output. Or I could write it more. So here I was writing it in a very functional way, in a very imperative programming way. So I'm writing a function and I try to match a packet and a rule. But we could also write it like we have a rule here, and we can just have a method called matches. See? I could give it a packet and see if the packet matches the rule itself, so I don't have to write this inelegant function here. So it's more like if rule dot matches packet. Here we go. Much cleaner this way, but we need to write some testing for that, which is good. So here it's like this test is already too far into integration. Here I should disable this test for the moment because it's going to run later, but not now. I should make a more narrow test, just testing if I create a rule from scratch. So if I just take a whitelist rule, is that yes, a whitelist rule here, whitelist rule, and a packet. So def tests it matches matching rules and packet. So if I say rule is whitelist rule and then I say src is 127.001 and port is 3. And now I'm crafting a packet exactly to match this rule. So packet is this. Assert rule matches packet. Let's forget this failing test for the moment. So X for breaking, S for not capturing the std out, and K for just running the one I'm looking for. What PyTest? Yes, of course. Sorry. Good. Oh, I still need to give it a name and a DST. Is it really? Do I really need to put DST? I'll just do it like this. Default is star, src is star, and name. Name is still mandatory. Okay, and this is name is DNS from localhost. Oh, it works. So while we are at it, probably we should add another test, a test that does not pass. So I'm just going to copy these tests and just change a few things. So let's say I want to make an HTTPS query, and this is the HTTPS query. This is the rule I'm allowing, but I'm not changing the packet. I'm still making a DNS query. And of course, this should not pass. It does not match, doesn't match unmatching rules and packet. Matching rule, not to confuse the future test maintainer. Okay, So now we've got a pretty good test. Let's go to the code. So what does it look like? Def matches self. Packet. Well, now let's look at the code. Okay, so these 3 dots. Is it? Ah, so if I use this here, it's going to it's going to return something, and my assertion is going to succeed. So I just pass here. So running my tests. Doesn't work. That's good because I have written none of my logic. What should it look like? What we want to do is compare each attribute from the rule against the attributes from the packet. What should it look like? So one way of writing it would be if src is different from star and self.src is different from packet.src, then return false. And then I do the exact same thing here with dst and so on and so on. It looks a lot like the same thing over and over, right? So let's write it a bit better. For attribute in src dst port, we're going to get the value of the rule associated with this attribute. So rule value is self get at, which is the function that is equivalent to if I do get at of self attribute is the same thing as self attribute, but it's more pleasant to read. If rule value is different from star and rule value is different from get attribute of packet and then attribute. So is this correct? Not really, because you see port here, I'm using port, but packet they don't have port, they have D port and S port. So it's not going to work. So what I should need to do is either I just make it, I hard code it, or I'd make it a bit more subtle, elegant. So I'm going to call this rule to packet mapping, and then port goes to D port. And now I'm going to break the line. So if rule value is different from star, so it means that we are really interested into matching the value. It's not whatever, it's something. So if rule value is different from star, then the packet attribute is self.rule to packet mapping get attribute. Okay, so this is over my 80 character limit. Okay, this is better. It's still very long, but it's below the line. So what does this mean? It says that, so I'm going to take my mapping, which is bound to my class here. So into my class, I can define also variables here that I can access. They are called class variables, and they are going to be available to all the instances of the same class. So here, if I do self.rule mapping, I get this, and then I use the get method of dictionary. The get method of the dictionary it takes the key if it exists, otherwise it takes the default. So for me, it's going to be like either if I'm passing src, src goes here, checks no src, takes the default. In default, I also passed src. So packet attribute is going to be src. So it's the mechanism for overrides. So if something doesn't exist, it takes the same element. If there is a corresponding value in the mapping, then it's going to take the corresponding value of the mapping. So packet attribute here is going to be it's going to take the right thing, and so now packet value is the attr of packet attribute. If packet is packet value different from rule value, then return false. I think if I had renamed every attribute to attr, it would have been a bit more readable. I could have fit everything in a few lines. But anyway, so what does it mean? It says that, so I'm going to get the value on the rule for a given attribute. So let's say src. I'm going to take self.src. If it's different from star, then I'm going to fetch, like first determine which is the corresponding attribute in packet, fetching the attribute from the packet, and then comparing the two. If they are different, means that it doesn't match. See? Here, return true. How can I be so bold of saying it always returns true? It returns true if we've been through all the attributes and we haven't found a single one which did not match. See what I mean? Something is true if you can't determine it's wrong. Like if you've tried your best to say it's wrong and you can't say it's wrong, then logically it's right. In a binary world where there's just like true and false, of course. In real life it's a bit different. Well, it looks like a pretty good function. Let's give it a go. Oh, get attribute name must be a string. Attribute, sorry. Oh, fantastic. So you see, it only run one test because I had -x and --lf, so it always run the latest failure. I'm going to run it again. Oh, runs everything, including my 2 tests in test pcap. So would that mean that, yeah, okay, we've got a matching engine that works now. So maybe if I uncomment this, let's check 888 DNS 2888. So src is, we could say whatever. I need to single quote it. So, or we can omit it. DST DNS2. Oh yeah, no, sorry. It was like from localhost. I forgot half of the sentence. So from localhost to 8888 on DNS. Good. So this should work because the first packet is DNS from localhost to 8888 on the DNS port. Oh no. What's wrong? src 120.8853. Take capture 1. 53. That's weird. So what's different? Oh, it didn't return a list. Hey, of course. Output whitelisted. Whitelisted should be a list. Here, Okay. Oh, great, it passes. Fantastic. So yeah, of course, so just to explain a bit more, so whitelisted is a list according to my filter packet function. This is initialized with a list and then everything goes here through there. And so of course this should be a list and not just fake capture of one. This is just a single element. Okay, that's great. Great, we have a working something. So now I think we've got something that kind of works. We can see in the next episode on how to like pipe everything together to have like a real user interface and wrap it up. Okay, see you next time.